Internet people. I want to discuss the time travel phone. That has the message from 2043. So, I don't want to say there was resistance to just mentioning time travel, but so when you take physics, there's like physics 1 and 2 required for my bachelor's in biology. If you're a computer science major, I think there might be a third physics, or you can take a substitute for it. Nurses, I don't think they might have to take the non-scientific physics. So the point of this is that there is a lecture that you attend, and so they lay it out, Einstein's theory of relativity, and you get to the point where there's the debate about time travel. The teachers know the impact this has on people who've never heard it before, and they know how long it takes for you to get over it and then move on, right? So I saw one of my professors, so I went in and took the entire class on relativity, and I saw professor go from the hypotenuse of a triangle directly to the theory of relativity and the famous Einstein equation. Now, the famous Einstein equation has equations that come before it, and those are the equations people are using. So if you notice, like old maps, they're very familiar with triangles, and the whole globe is measured in triangles. So you kind of wonder, well, what else did they know? If the Pythagorean theorem, which is the square root of x squared plus y squared equals z, which is the diagonal line in a square. So the ancients were drawing their maps with these triangles. Okay. And all of the ancient monuments, without exception, are tied to each other in straight lines. The Pyramid of Giza is in the exact center of all the land masses on Earth. There's, right, so, and they're triangle. You can go from the Giza pyramids to like Easter Island and all kinds of shit like that. Mind-blowing shit. There's even lines for when the equator was in a different position and the Earth was tilted. So you could put together any number of different time frames for when the equator was different, the poles was different. There's a formula on the door of the pyramid. And the first symbol is a V, or a triangle. And that's the only inscription on the Great Pyramid. The Red Pyramid has a causeway. They all have causeways. The Red Pyramid has a causeway going to a river. It could be the Nile, that is dried up and is not even there. The other ones have causeways that look like there were temporary diversions of the river Nile going to the pyramid, and they loaded the blocks on the pyramids, right? To me, the star alignment shafts were how they sighted the stones. Or they could be collecting certain wavelengths from those stars. For seeds or something. Let's say you put a seed in a dark room and you have the starlight from a star. Will it change the seed's DNA? Right? Let's say you stuck a pregnant woman in the base of the pyramid and gave her starlight from Orion. Maybe that produces the queen and drone with the elongated skulls, and we are the worker bees, right? Okay, so for me, those shafts leading to the stars are not that big of a deal. The placement of the pyramids are on this triangle alignment system, whereas we use longitude and latitude. So we have all kinds of problems with time zones. There's, for example, Pacific Mountain Time, Central Time, Eastern Time, Mountain Time. But that's not the only thing about time. If you just have an atomic clock and you synchronize it with another atomic clock, and you put one on the ground and you take off on an airplane and go around the world, those two clocks don't match. Maybe this triangular coordinate system is how they kept track of these time shifts, right? So it's not that much of a drift, a second, right? But the satellites are drifting a lot more than a second. They're going a lot faster. They're higher in the altitude. So what does that have to do with the ancients? There's a satellite in orbit that they think has been up there for 75,000 years or something like that, right? Orbits that couldn't be achieved when they discovered that satellite. When you launch a satellite or a rocket, it doesn't go where you think it goes because of you're not able to calculate the straight lines because of the time drift, time dilation. Okay, so we're in a time drifting society right now with satellites. Have to be coordinated, or they're all squarely times. And our cell phone networks, our GPS, have to be constantly calibrated, right? All the airplanes in the at a certain control tower of a runway have to make sure that all the airplanes coming in and out have the same time stamp, right? So it's a mess keeping track of all these times. Now, imagine if you fly to the moon or Mars, right? It's a lot more time drift, time dilation. So, you read all kinds of things in the mainstream media. Oh, they proved Einstein's theory. They disproved Einstein's theory. All this, that, and the other. Every technology, computers, telephone, satellite, GPS, especially GPS, are being corrected with these correction factors mathematically using Einstein's theory of relativity, right? Which gets into time travel. So like I said, the physics professors know when the shock hits you, they know down to the minute how long it has to be discussed in the class. They're like, okay. And they go, okay, you guys are over it now. Time travel. So I have a phone that shows the date of the year 2043. So that's a whole nother level, obviously, right? So if you know anything about electronic signals on a wire or transmission lines, it's not the same electron that goes across. One electron bounces to the other, bounces to the other, bounces to the other, bounces to the other. So at one point, this is what a satellite gets a solar flare. You may have heard the absolute elsewhere. They get these calculations, and then they get a point in space that's absolute elsewhere. They don't know where it is, right? So glitch in the matrix. So you have a bunch of different physicists running around. You have a guy that operates a ham radio. He is aware of the electronics, the calibrations, the corrections, and that person suspects, there's a lot to the errors, the drifting, the ionosphere. There's another type of physicist, electronic technician. So there's a type of electronic technician that sees a repair and he swaps the circuit boards, right? And then you may bring the circuit board back and try to isolate down what to repair, and then that's your spare board. Then the guy, maybe there's another guy who does on-board repairs, right? If you blow a chip, you got to buy another chip and put it in the board. There's another type of physicist called an engineer. and he has a handful of parts in mind. He comes up with a drawing and puts it all together. And you know, when you start designing equipment and you plug all these parts together to your drawing, wacky shit happens, right? So you discover all kinds of stuff. We got all these other calibrations and configurations, and well, we thought it was this resistor or capacitor. We got to put in this other resistor or capacitor, and we're observing this signal and stuff like that. After the engineer, you have the PhD in physics, and he knows what all of the calibrations mean and all kinds of stuff like that. There's an engineering technician that puts the interface between analog signals and digital to a computer. That's the wackiest, craziest shit you've ever seen of all, right? So the physicist is like, let's put these math formulas in the software. The software won't take it. You have to make all these manipulations, and it doesn't look like the formula you thought it looked like, right? And then you put you hook up that to an interface, analog to digital converter. So this electronic signal comes into the equipment that you've designed. It converts to a digital. The digital goes into the software. So all of these are unknowns, like you're making these adjustments and calibrations and everything. If you look, you're going to see quantum effects, relativity effects. All of the theories of the universe are in every piece of equipment, right? So my phone had a glitch from the year 2043. So, solar flare, or, you know, that's a lot of electronic drift. So if you know anything about a black hole, as you get closer to a black hole, the time slows down. So the Earth and Sun are like a black hole, and the time slows down. As you get further out, you get different times, faster and faster and faster. So, don't know, time shift, right? So like, I wrote a paper on wormholes. I had the mathematics laid out. If there's a wormhole mathematics, then it's happening somewhere in the universe. If it's happening somewhere in the universe, it's possible to duplicate it, right? I never thought I would see a glitch like that on my phone, but I bet these are happening all the time. I bet that if people were paying attention to their electronics and their engineering and their phones and everything, you'd see a little bit of a hint of what's like going on around you. You know, it's not just Instagram and Facebook. The universe is really wacky. You start building equipment from scratch, you get to see some of the real universe, and no one knows what's going on. You know, so But yeah, there's a lecture about the time travel, and then they let the students argue all the time paradoxes, and then that's it. You know, but there's no one saying that there's no such thing as time travel. I watched a video on Stephen Hawking building like a wormhole gate, and he's saying that the feedback would prevent you, you know. So that's there's that, right? There's like guys, there's a couple guys, different guys, you know, trying to make a time machine, you know. What I find is interesting is in the 1800s, the time machine came out, and Jules Verne had all this stories, these fantastical stories in the 1800s. All of Tesla's materials came a little bit later. What happened in the 1800s with time travel? They were considering time travel there, you know. Uh, 1903, I think, is one of Einstein's papers. So we've had this for a while, and so the time travel, we're already there with the time travel, you know. Right now we're just adjusting. Oh, we better adjust this clock. You know, they just crank it like, and they go, okay, there, we can ignore the time drift. But it's going to be to a point, if we start circling the moon or Mars, you're not going to be able to adjust a little set screw for this time drift. You know, it's going to be, I bet you when you fly to Mars and back, there's going to be a huge time drift. And it's going to, this is going to be where, like a Star Trek Prime Directive, you know, my cell phone that reads 2043, I kind of feel that responsibility for the Prime Directive. Like, okay, so I didn't feel a thing, and nothing happened to me physically. You know, I don't have knowledge of the future. Knowledge of the future is something that I could put together. I wish I would have invested in Bitcoin. Right, I didn't have this information. Invest in Bitcoin. You know, if I would invest in Bitcoin, I would have been a lot more wealthy if I would have invested in Bitcoin. So that's the time travel phone.